plus 17. Let's take a look at problem H. In problem H, I notice if I were to try to do AC method right off the bat, I have very large numbers, which sometimes happens, especially in my math lab, but as a general rule, you shouldn't have really big numbers. So my wonder is there something I can do first to make my numbers smaller? And there is, because we've got a 3, a 30, and a 63. They're all divisible by 3. So before I do anything, I'm going to do what we did way back at the beginning when we learned factoring, which is pull out a common factor of 3. Then the question is, what will be left over? We have to pull out this common factor of 3 from each and every piece. So in the first piece, pulling out the common factor of 3 will turn into just an x squared. Plus, now pulling the 3 out of the 30x will leave me with just a 10x. And dividing the 3 out of the 63 will leave me with a 21. Now I'm not done. Now I can still do AC method, because I still have 3 terms on what was left over inside. The problem is that 3 out in front is not going to disappear. And I don't want it to disappear. So I'm going to carry it down to the bottom to my final answer so I don't accidentally lose it. Because I still need to do AC method on this x squared plus 10x plus 21. So my AC method, my A, which is hidden, is 1. Remember, the 3 was out in front, so that's not your A. Your A is 1, what's in front of the x squared here. Your B is a positive 10, and your C is a 21. So when we go to do our AC method, our A times C is 1 times 21, which is 21. I need 2 factors of 21 that are going to add up to my middle piece, my 10. That's going to be probably the first thing you can think of is 7 times 3. That 7 times 3 will give you the 21. So that works out. But it also, 7 plus 3 does give you positive 10 when you add it up as well. So what that tells us is if we want to break up this 10x is that we're going to break it up into a 7 and a 3. So that this will break up into a 7 and a 3. Again, they had x's before, so when I split it up, they'll both have x's. And then my first term stays the same, the x squared, and my last term, the 21, will stay the same. So I can just bring those down. I can bring down my x squared and my 21. Now I've got 4 terms, so I need to do my grouping. So what do the first 2 have in common? They have a common factor of x, which will leave me with x plus 7. The second 2, I have to carry down the plus, but they're both divisible by 3, which also leaves me with an x plus 7. And that tells me I am on track because I have my matching x plus 7 I can now factor out. So I'm going to put that out with my 3 that's already there. Is my common factor of x plus 7. Whatever's left over is going to go in another set of parentheses. That's my x plus 3. So everything gets done the same as what you would have done normally. It's just we factored out this 3 first, and we didn't want to lose it, so we just carried it down to the bottom. That is the most commonly forgotten thing when you write your answer on a test. So get used to kind of either bringing it down, or if you're doing this in my math lab, just type in the 3 so you don't forget it. But a key thing is showing your work so that I can give partial credit with these, because it's very easy that this is so detailed. It's not necessarily hard, but it is detailed. So you have to be careful that you aren't losing things along the way. Let's take a look at I. In I, we've got 3x cubed minus 12x squared minus 36x. Again, I notice that we've got pretty large numbers again, so let's see if there's anything in common that we can actually factor out first. Well, we've got a 3, a 12, and a 36. 3, 12, and 36 are all divisible by 3, so I can factor out a 3. But there's actually more. I have an x cubed, an x squared, and an x. That means they all also have at least one x I can pull out. I want to pull out, remember, the greatest common factor, everything I can possibly pull out. So I'm going to pull out a 3 and an x from both pieces, or from each of the 3 pieces. Let's see what we'll be left with. On that first piece, if I pull out a 3 and an x, I still have an x squared. I still have 2 x's left. Minus, factoring the 3 from the 12 on the second piece still leaves me with a 4. Pulling out one of the 2 x's means I still have an x. Don't forget, I still have to pull the 3x out of the last piece. So minus 3 goes into 36 12 times, and pulling out the x means it will be gone. The question is, are you done? You might be, you might not be. You still have to check your x squared minus 4x minus 12 to see if you can do AC method on it. So let's talk about that. Our A, you can't see it, is 1. We've got a B that's going to be negative 4. And we've got a C that's negative 12. We'll have to check that out. However, I do not want to lose all my hard work. I pulled out a 3x. I don't want to lose it, so I'm going to carry it down to the bottom so I don't forget it. That should still be out in front of my final answer. So let's do our AC method on this x squared minus 4x minus 12 and see if it can work out. So off to the side, I'm going to do my A times C, which is going to be my 1 times, let's see, negative 12, which is negative 12. And I need 2 factors of negative 12 that are going to add up to negative 4. Well, that's going to be a negative 6 and a positive 2. A negative 6 and a positive 2 do give me the negative 12, but it also does add up to a negative 4. Remember, if you do want a negative, when you're multiplying, the only way to do that is if one's negative and one's positive. Okay, so now what? What do I do with this negative 6 and positive 2? Well, I'm going to use that to break down my middle piece, my negative 4x. So it'll break down that middle piece into 2 parts, a negative 6 and a positive 2. The middle piece had x's before, so it's still going to have x's when I break it up. My first piece, the x squared, stays the same, and my last piece, the negative 12, stays the same. Now I've got my 4 terms, and all I need to do is my grouping. So let's see what I can do with my grouping. Well, what do the first 2 have in common? They both have a common factor of x. So if I pull an x out of each piece, we still have an x minus 6. The second 2, I've got a plus out in front. And the 2x and the 12 are both divisible by 2. So I can factor that out of both pieces. That will leave me with an x minus. Well, the 2 will go into 12 6 times. And this should make me feel really good because now I've got a matching common factor, which is what we need to have happen. We've got the matching common factor of x minus 6, so I can pull that out in front where my 3x is. And then my leftovers will go inside of a new set of parentheses. What are my new leftovers? It's an x and a plus 2. So there's my final answer here is 3x times x minus 6 times x plus 2. And again, the most commonly forgotten thing is they lose the 3x along the way. It's so easy to accidentally do.